Okay, so in this video, I would like to talk about the consumer problem. So in a microeconomics course, you will have to be quite well averse in solving a consumer's problem. So in the previous video, we looked at a market simulation where the willingness to pay for the consumers were just given to us exogenously. And now we're going to have to think a little bit more structurally of what determines demand. How can we think about the demand of the consumers? And in most microeconomics courses that you're going to see, you're going to focus on a too good problem. So what we're looking for is we're looking to maximize a utility function or a happiness function that will include two goods. I'm calling them X and Y. If you like, you can think of them as food and shelter. Okay. So everyone needs food and shelter. And I would like to have a function that tells me how happy I am with different levels of food and shelter. But economics is a science of trade-offs. It's about allocating resources under or scarce resources. So we're going to have trade-offs. And the trade-off here is that you're going to have a set amount of money or income which will be spent on these two goods. So the total consumption, the total expenditure will be the price of X times how many units of X you consume. That's how much you spend on X plus the price of Y times how many units of Y you consume. So that's the expenditure, and the expenditure must equal to income. Now, of course, I can think of this. I can think of this as, the expenditure should be less or equal to income. But for most of your microeconomics courses, we're going to make the assumptions that having more of X and more of Y is a good thing. So we would want to exhaust all of our income, and we'll leave it for a later day to discuss a multi-period consumption. Right? So here we're thinking about one period, right? How many units of X and Y would you consume given a certain level of income that you have? And what I would like to first focus on is the budget constraint. So this is what we call a budget constraint. If you want to solve problems in consumer theory, the first thing is to look at this budget constraint and say, do I recognize it? Am I able to plot it? Am I able to do so comfortably and quickly? And here's my favorite way to think about a budget constraint. My favorite way is to first plot your favorite plot here, x, y. Okay. Um, what will be the maximum amount of X that I can consume? Well, it would be if I spend all my money on X. So if I have 10 pounds and X costs 2 per unit, then the most that I can do is 10 divided by 2 is 5 units of X. I can do the same. What is the most amount of Y that I can purchase? Well, it's the money that I have divided by the price of Y. I connect these two together. I have a budget constraint. What's the slope of this? Well, think of this as point A. Think of this as point B. Think about moving from point A to B. What's slope? It's rise over run. Okay. So if I'm going to look at the slope, going from A to B, if you like, it's rise from A to B over run from A to B. What's the rise? Well, actually, I don't rise when I go from A to B. I actually go down. Okay. So it's a fall or it's a negative rise. So minus m over py, all of this divided by the run, right? As I go from A to B, I run m over px. I start at 0, so I run a positive m over px. Division of fraction is the same as a multiplication by flipping it around, so negative and positive will leave me with a negative, so I'll have minus m over py times px over m. They will cancel. The slope is px over py. Okay. Um, if you want an interpretation of this slope, of course, if the price of x is 2 and the price of y is 1, right, then the slope will be 2, right? Which means that when you give up 1 unit of x, okay, you release 2 units of income, right? And because the price of y is only 1, you can purchase 2 units of y. So a slope of minus 2, if you like, tells us that you can trade in the market 1 unit of x for 2 units of y. Okay, if that is the pricing. So the first thing is think about the budget constraint, which we've now covered. Next is to think about, oh, all right, if I can believe that, right, it's a fair assumption to make that more of X and more of Y, think about it, it's easy to dispose of these goods and they give you more benefits or more food. We can envision some situation where having more food will be detrimental to you, but not if it's easy to dispose, right? And certainly more shelter will be always welcome, right? You could always be a bigger home. Um, so if you make that assumption, then the consumer problem simply becomes, okay, I have infinitely many points on this budget constraint. Which point will give me the highest utility? Okay. Now, if you think about the utility function for a moment, um, if you try to visualize it, you could. You will have an x-axis, a y-axis, and a utility axis. So it's a three-dimensional graph. So if I think about trying to visualize a utility function, and mind you that I have not given you a utility function, right? So think about a floor, x and y. You can visualize this in the room as the x and y being the floor, okay? Visualize your room, look at a corner of a room, okay? One side of the room is the X, the other side is the Y, okay? As you move away from that corner, right? So here's the corner of the room, you get 0 of X, 0 of Y. As you move away from the corner, but you are on the floor of your room, okay? You will get some values for X and you'll get some values for Y. And if you want to know the utility that you get, you will have to look at how high up you are, right? So you can visualize maybe a function that maybe looks like this, okay? So visualize this in three dimensions. It kind of covers your whole room. And you can, if you like, if you want a visual of it, you can visualize this as bringing out a sheet, okay? And having a sheet sort of cover the whole, starting maybe at 0 and then going up as you get more of X and more of Y. And it could be a bit wavy, that sheet, okay? Or it could be nice and smooth, like the one that I've drawn here, okay? Now, it's a bit more problematic to work in three dimensions. So what as an economist, you'll realize it's a lot easier if we deal with what are known as level sets. So we go to this sheet and we say, oh, okay, like if I just want utility of 10, okay, and imagine in your room, slicing horizontally, having a piece of paper slicing through that sheet. Okay. Well, that sheet will slice through multiple points of X and Y, right, that give you that utility of 10. Okay. So if you trace those points of X and Y, that maybe give you that utility of 10, you will find what's known in mathematics as a level set. Applied to this economic context, we know those as indifference curves. So what are indifference curves? Are combinations of X and Y that give you the same level of utility. Okay. And because more is better, the further I go this way, the more utility that I get. So how could I visualize this in different curves? Well, they could take multiple shape. And in the following videos, I'm going to look at different sort of classical shapes that you can look at. It could be that indifference curves or level sets are linear. Maybe they are like this. And if they're linear like this one, right, as I pull out, I make more, I duplicate more, you can realize that the best thing that you would be able to do, and of course they extend all the way. So I'm not going to be doing this early. Here we go. Make this as much of a line as I can. And of course, one possibility is that they're all parallel. They don't have to be, but in most cases they would be. So the solution here is, aha, I had a very difficult problem. There's infinitely many points. Out of this infinite many points, which point would give me the highest utility? It's the point on the budget constraint that sits on the highest level set or the highest indifference curve. That could be one version of the indifference curve. Another version of the indifference curve, if I go and copy this, could be that they look like nice and smooth like this. So it could be that they look like this. If they look like this, maybe we're going to get something known as a corner, as an interior solution, right? It's not on the corner of the budget constraint. This would be a corner solution. So it's at the corner, one of these variables is 0. Okay, so it's a corner. This would be an interior solution. Another possibility could be that the indifference curves look like a V-shaped. Sorry, an L-shaped. Right? So they might look something like this, for example. I'm drawing that red line to indicate that they're all having the kinks of those are along a particular line. This is going to be our perfect complements. Um, so if I focus on this big picture, the consumer problem is uh, it's two parts, okay, or three parts if you like, and we'll cover. The first part is you need to understand the budget constraint. The second part is that you need to understand that the preferences for, let's say, this X and Y or food and shelter come in various shapes. Um, and you need to, for each of those classical shapes, be very comfortable to solve this maximization or consumer problems. And in the next video, we'll take each of these classical ones. So this smooth one, this linear one is perfect substitutes. This smooth one might be a Cobb-Douglas, or it might be a quasi-linear, and this one here would be a perfect complement. We could have also what are known as non-convex preferences, where your preferences could look like, let's say, like ovals or quarter circles, right? So maybe they look like this, right? And you could see that if that's your indifference curves like that, then again you could end up in a corner solution. And we'll study each of those in the videos to come. Stay tuned.